We're asked here to find the product of two vectors, that is C cross D, where C is the vector 5i minus j plus k, and D is the vector 3i minus 3j plus k. So what we can do with those vectors is put them into a determinant form and then use that to find the vector product. So we'd write here along the top of the determinant I, j, k, and the components of C, 5 minus 1, 1, and the components of D, 3 minus 3, 1. And then we evaluate. We'll go along the top row, so each of the unit vectors, remember what we'll do, we'll get rid of the ones in the same row or column as the unit vector we're interested in. So then for the remaining 4 elements, start off with the one down to the right of that unit vector, multiply by the opposite one, and subtract the product of the 2 remaining ones. So for I, we have the 4 numbers here. 1 minus 1 times 1 minus 3 times 1. And then j, start off down to the right. Don't use those ones, don't use those ones. So 1, 2, 3, 4. Start off down to the right. 1 times 3 minus 5 times 1. And then for k, don't use these ones, don't use these ones. Down to the right takes us round the end to the 5 here. So we have 5 times minus 3 minus 1 times 3. So our vector product here is minus 1 plus 2, so that's 2i, 3 minus 5, that's minus 2j, minus 12k. Now we can check this. This vector should be perpendicular to both of the original 2 vectors. So let's take the scalar product with C, then we'll take the scalar product with D. So scalar product with C, 2 times 5, that's 10. And then we add on minus 2 times minus 1, that's 2. So 10 plus 2, that's 12. Plus minus 12 times 1, 12 minus 12 gives us 0. And then just to be absolutely sure, we can take the scalar product with D. 2 times 3, that's 6. Plus minus 2 times minus 3, that's another 6. That gives us 12. Plus 1 times minus 12, 12 minus 12, it gives us 0. So we have our scalar product, we have our vector product, C cross D is 2i minus 2j minus 12k.